video, I want to start thinking about doing unsupervised learning on this kind of data set. So what do I mean by unsupervised learning? Well, I mean that I now don't assume that I know the labels y. All I have is the x's. So let's say that that's the case. So in that case, what do I even want? What do I even want from this kind of data set? Well, one thing I might like from this data set is the probability of the entire data set. So P of x, I don't know the y's, right? And I want this probability under the parameters of the model to be as high as possible. Why would I want that? Well, because essentially I want to say, okay, so I want to find parameters such that this data set is likely, right? So what kind of parameters would be kind of unlikely for a data set that's like that? Well, for example, parameters that say that dog and homework never appear together in the same email, well, those kinds of parameters would be bad. Parameters that say that dog and homework and also dog and kennel can appear together, those would be more plausible. What would be the most plausible parameters? Well, arguably, those would be the parameters for which this probability is as high as possible. So parameters such that if I were to try to generate lots and lots of fake emails using them by first picking a y and then generating the x's given the y, I would keep getting data sets that are kind of like this training set, or maybe even exactly like this training set, because the model assigns a high probability to those kinds of training sets. Okay, but what is this? So, well, the easy thing is to say, well, that's the product of the individual probabilities for the individual training cases, right? So the product over J of P theta xj. But what's the probability of x? Well, and by the way, theta here means all the parameters of the model, right? So we can even say theta and also pi, theta and also pi. So what do we mean by this? Well, one thing we can do is we can just say, okay, so the probability indexed by theta and pi of xj. Well, we can't compute this directly, but we know how to compute the probability of xj given a y. So why don't we do that? So we'll say that's going to be just equal to, according to the law of probability, the sum over all the possible y's of p theta pi xjy. So this is just the law of probability. So here we're getting closer to something that we know how to compute. So we can expand it further and say that this is the sum over all the possible y's, p theta pi of xj given y times p of y. Okay, and this we know how to compute. So theta pi, we got it, right? So this we know how to compute. So p of y, well, you just look up the pi and it's going to tell you what p of y is for every value of y. If you set the y, and here y is all the possible values, right? So here y is a particular thing. So again, you can compute this, and you'll just use the naive Bayes assumption in order to factorize this further and compute it. If you know theta and pi, there is no problem. So one possible goal when doing unsupervised learning is to just find those theta and pi such that this value, where x is the training set, is high.